we use a little diagram to help us solve our solutions when we have more than one answer. It's called, by some people, the CAST diagram. You get your fingers wrapped for that. By some teachers, other teachers call it the ASTC, and other ones use different acronyms. A lot of people find the more rude they are, the better they remember it. So ASTC, so all smokers take cancer, or something along those lines. I call it the CAST because that's what I was taught back at school. Now, where on earth does all this come from? All right, and why does it work? Now, if you're working with positive curves, let's say sine x equals 1/2, what we're going to get is we're going to say our solution is what comes out of our calculator here, and that's an answer between 0 and 90. So if I start here being 0 degrees, right, my calculator is going to give me a solution between 0 and 90. Okay. Basically, it's in the first quadrant. Okay. That's also positive if I'd said, when is the tan curve at height of half? Well, also, it can be found somewhere between 0 and 90. And also, if I ask the same question, when is the cos curve at height of a half? Well, the answer can be found somewhere between 0 and 90 as well. But if you actually look at, let's say, the sine and the cosine curve, there is a slight difference here. The cos curve dips below the x-axis at 90 degrees, while the sine curve is still above it. So what we have is our second solution for sine curves can be found somewhere between 90 and 180. All right, and the way you find it is you find it by taking whatever your calculator gives you and subtracting that value from 180. So basically, your first answer comes out your calculator as x, all right, and it will be between 0 and 90. And your second answer for sine can be found by taking that away from 180. And the reason why that is because of the symmetry. So my curve here is x degrees away from the x-axis. So if I put my calculator, the inverse of sin half, I'll get 30 degrees long. But it's also 30 degrees short of 180. Okay, because of it's the same distance. This is the same distance as this is. So my second answer is worked out by doing 180 take away x. Tan graph, that's the second quadrant. So that's your first quadrant. That's your second quadrant. So every single sine graph can be found, the second solution can be found by doing 180 minus x. The second solution for a tan graph is found in the third quadrant between 180 and 270, i.e. in this quadrant here. That's my second solution. Now, whatever you work out for a tan equation in the first, you get is x. Well, to find the second solution, you just add it on to 180. And we can see why that works. Because our value you get from our calculator is x. This tells you how far along the x-axis you've gone, in this case to reach the height of 1, which would be 45 degrees. Well, the second time that occurs for a tan curve is 45 degrees away from 180, i.e. 180 plus 45. Finally, for cos curves, you have your different solution again. It's in the fourth quadrant. All right, the fourth quadrant is between 270 and 360. Now, if you have a look at full rotation, that'll be somewhere between 270 and 360. Now, That's the final one. Whatever you work out, your calculator gives you the value of x is. That's how much short of 360 you are. So that distance here is the same as that distance there. You can see that roughly in my sketch. So to find the second solution for a cost graph, you do 360 minus the angle that comes out your calculator. So basically, there's nothing mathematical about this. It's just a way of helping us remember those facts, remember the symmetry. I actually found that by learning how a cost curve looks, how a sine curve looks, and how a tan curve looks, I had a better deal at remembering how this worked. All right, this was just the thing that helped me remember that. To find my second solution for a cost curve, I do 360 minus the angle I work out. For a tan one, I do 180 plus the angle I work out. For a second solution in a sine, I do 180 minus the angle I worked out. Now, I'm going to put a little caveat at the end. That only works, and this only works perfectly for positive angles, or positive values, sorry, on the y-axis. You have to do another little trick if you're dealing with negatives, but your teacher will go over that in class, all right?